Our next session is Event-Driven Systems as a Vehicle for IoT and Digital Transformation. So we're going to bring up VANTIQ, Marty Sprinzen. Welcome to the stage.
Thank you. Okay, I have the challenge after lunch of keeping you all somewhat awake, and I figured I've been told that the brain uses the most glucose, so I'm going to try to challenge you a little bit about thinking and get that brain going. Now, first of all, can we get the presentation up, please? Okay. Okay, got that one. We're off to a roaring start here. Okay, so to get you thinking, I want to introduce an analyst to you, somebody who analyzed social and political situations quite a while ago. He doesn't work for Gartner. In fact, he doesn't work for any firm because there wasn't much technology then. And I'll give you a quote from a book that he wrote, and you'll know who he is right away. And then I'm going to compare it to today. And the quote is, "It was the best of times. It was the worst of times. It was the age of wisdom. It was the age of foolishness. It was the epoch of belief. It was the epoch of incredulity. It was a season of light. It was a season of darkness. It was a spring of hope. It was a winter of despair. We had everything before us," etc. Charles Dickens, right? Tale of Two Cities. Now, interesting, because of course he was comparing France and England, but what he was talking about were issues, major issues back then. And of course there were no technology. But if you look at what he said, age of wisdom, age of foolishness, can we relate that to IoT? Perhaps. A lot going on, a lot of smart things we think we're going to do. Epoch of belief, oh, we believe we can automate everything, get rid of jobs, etc. Epoch of incredulity, yeah, this is a difficult thing to do. Season of light, oh, we have sensors everywhere. Season of darkness, we have problems everywhere. Terrorism, safety concerns, etc. Spring of hope, we can cure this problem. Winter of despair, we had everything before us, blah, blah, blah. So, he should have worked for an analyst firm. Anyway, what I want to relate that to is, and I've been in this industry 37 years. I've seen it all. I started in 1980. In fact, I knew Al Gore, and he said, "Can you create some software so I can create the internet?" And I said, "Sure." At any rate, I've seen a lot of change. I mean, I started off really in 1GLs because I did PLC programming when I was an engineer. 2GLs, assembly language. 3GLs, that's really where I spent my time. 4GLs, we created some. In fact, companies I previously worked for with my co-founder Paul Butterworth, this is the 4th application development environment or application development platform that we've created. So we have some experience there. What I want to talk to you about today, though, is if we just take linear extrapolation, make things a little bit easier, it ain't going to work, guys. We're not going to create the software that's needed. This is a serious problem. We need different paradigms of how we create software. It's more than just IoT. It's IoT, it's legacy systems, it's these intelligent devices. How do we get everything to work together and get people involved? This is a major challenge today. But like Charles Dickens' time, challenges got solved. Now, if I could be a little bit corny, perhaps, one of the ways the challenges got solved back then was there was this startup country called North America, really rebellious, and they, of course, took over a lot of the world economically. And now, of course, we have technology in Silicon Valley, etc. But the stuff we have today is not satisfactory. So the major theme I'm going to talk about in my presentation this morning, which I've changed to people, places, and things, but the theme I'm going to talk about is how do we get out of this quagmire? How do we develop very complex systems very quickly? And I'll give you a hint. And the word, actually I won't give you a hint. We'll wait for a minute. Okay, let's talk about the problem. Now, we all know the problem. We read it everywhere. Companies are expected to go out of existence even faster than this, which was, average was 75 years, now it's 15. I've seen, who was it? It was John Chambers was on CNBC recently. He said 40% of the current companies are going to be out of business in a record period of time because of the changes in technology. Tom Friedman, in his latest book, said that change is accelerating. Okay, so that's a second derivative. How many engineers do we have here? Okay, enough. Then he went on to say that this third derivative is positive. In other words, the rate of acceleration is accelerating. And then he even touched upon the fourth derivative. So how can we exist? Either mankind is going to go out of existence because there's too much technology, too much for us to learn and use, or we're going to find solutions to it. And the solutions, I'll say now, are abstractions, ways of building systems unlike anything we've done before. Interesting concept, and I'm going to show you some examples of it. So that's one of the problems, and big companies, we don't want them all going out of business. We want them to last. How do they figure out how to develop systems? Well, the technology revolutions are clearly here, and they're going to stay. If any, there'll be more. The cloud revolution, smartphone, IoT revolution, AI, microservices, blah, blah, blah. The point is, we keep on adding new technology stacks, more things to the systems that we have. And on top of that, there's another problem, the real-time requirements, that these systems have to run in real time. Previously, batch was satisfactory. According to Gartner, by 2020, 50% of new end-user applications will be event-driven applications. Those are all applications, basically. So 50% of applications could be event-driven, different paradigm than we're used to. How do we adapt to that? Previously, building systems, building applications was relatively easy. We automated the existing business, and we still do that today. Isn't CRM, Salesforce.com, and Workday just an automation of the way companies run? Basically, it is. Add some additional functionality for sure, but it's basically automating what we have. Same thing with Amazon's app, e-commerce app. It's automating what we already, well, it's e-commerce is new, but it's automating what we can already do to an extent that it's impacting other retail outlets, of course. But now we have a new problem. And the new problem, which IoT is, if anything, the primary factor in creating this problem, in that systems are going to run everywhere, and they're going to have sensors everywhere, and they're going to monitor the whole environment. In ways, I'll talk about one way in a second, in ways we've never thought about before. For example, there's new technologies, facial recognition. Facial recognition will be able to tell if you're an employee, maybe even if you're a terrorist, possibly if you're on the FBI's wanted list. Now that's pretty powerful, but where's it going to exist? We have a customer we just signed up in Japan who we're working with. We're going to create the software. They're going to create security systems, thousands of cameras all over private industrial sites that will recognize you walk through that door, you're an employee, you're okay. Or you've just been fired and you walk through that door, that's a problem. Or you're somebody who shouldn't be on premises, or the timing is wrong. Or in this particular location, we always want two people. We never want someone to be alone. And recognize other stuff. Now, what do they do with it? Well, they're not going to have 50 people sitting by video monitors monitoring 3,000 screens. They're going to take that information and do analysis, put rules on it. What action should be taken? Should somebody ask them why they're there? Should the police be called? Is it a major security breach? And these types of systems are around the corner. This company that we're working with expects to have these systems in the market in a year or two. Now you can carry this over. Facial recognition is a major change. It's going to be able to track us everywhere. And add to that augmented reality types of stuff. Like beyond facial recognition, people have other things that can be measured. Even olfactory type stuff, if you want to get really carried away. Possibly retina recognition. So we can be super accurate with that, and that will happen. And I'm telling you, it's around the corner. I was surprised. Met with two companies in Asia. One of them is producing the cameras, which will have logic, because over the internet you can't send too much data, or even over a private network, so it gets all these points. And then the points are sent to a server which has all the faces on it that will recognize, and the accuracy they believe is going to be 99.999, better than fingerprint recognition. These systems are around the corner. And these systems are going to be highly complex. And the system I just described, as I said, there aren't going to be 50 people by monitors. It's going to tell people when there are threats. So it's a collaboration type system. And one of the major points I'm going to talk about this morning is how we're ignoring the human factor in our industry. And that's going to be a major requirement. But building these types of applications is exceedingly hard. Dealing with asynchronous events. How do you deal with events coming in today at any rate, for example? You might have 1,000 events a second today. You might have 1,000,000 events a second in just a few years as these sensors proliferate everywhere. And systems need special functions to do that. The old systems will not scale. You don't want queuing. You want to deal with the events as they occur. There are techniques like something called reactive programming, which is an architecture under the covers so there's no queuing. It'll scale horizontally, unlimited. If that doesn't work, vertically with distributed systems. Other problems. Everything has to happen in real time, or the data becomes worthless. Distributed. Where's the software going to run? Software ain't just running in the cloud. It's going to be running on intelligence sensors, edge computers. It's going to be distributed. And as I said before, we want to include people. Now, these challenges are actually very significant to build new systems. So current means of developing, deploying applications are not adequate. That's a fact. Now, I have to say that's why VANTIQ was formed, to raise the level of abstraction, to enable a whole new generation of systems to be developed that would be almost impossible. It's low code would be the term that's often used in the industry. But it's very different. It's rethinking through the problem. Now, we're doing that today. We expect competition. Other companies will do it. But it's not just going to be a 4GL or easier ways to program. It's going to be new techniques, totally new techniques to develop systems. Otherwise, like the old AT&T problem, all the telephone load that occurred in the, 40s, they said every high school student would have to be a telephone operator. Well, not every high school student or college student is going to be a Java programmer. We need easier ways to develop software so that the programmers, the developers, can be orders of magnitude more effective, more productive. Okay, if we look at the complex systems as I spoke about, it's hard for me to see. Oh, it's easy for me to see. All I have to do is look down. I tend to look up too much, I guess. Anyway, these event-driven business applications we're talking about, which, as I said, Gartner says is the future of how applications are going to be built, need abstractions. And some of these abstractions are the ability to deal with events at a very high level, to aggregate them, to analyze them, and streaming data. For example, when motors start to go off kilter and you want to do machine learning, there are ways to analyze them. There are simple things like temperature, flow. There are more complex things, like what frequencies is it vibrating at? Something called, when I was an engineer, fast Fourier transform. They could actually analyze what's happening in the engine, see all the discrete frequencies, and say, we have a problem. There's something even better than that. One of the ways that people notice when there are problems with motors, for example, is the operations people walk over and they listen to it. They hear the motor vibrating. They're actually kind of doing a fast Fourier transform in their head. Oh, that frequency is a bad one. I know this thing is going to collapse. Why not take snippets of sound and the information, the technical information, and feed it to operations personnel in a collaborative way? Say, we've noticed a problem here. It's at this level of a problem. It's real serious. And this motor or chiller or whatever it is may collapse. And then you could get the people to look at it when the event is occurring. Now, those are abstractions that are really dealing with events. Some of it may be machine learning. A lot of it, though, machine learning is great. We are a strong supporter of it, and AI. And in many use cases, it is really the only solution. It adds huge productivity to how people operate. But in some cases, the operations personnel know what to do, and if you could just programmatically add that to the system, they can fix the system on the fly. Take that expertise before they leave and do it. Have to figure out timing here. So that's with events. With distribution, I had a company before that we did that. We raised the abstraction level for distribution. We made it so you didn't see when software was being distributed. And I'll show you an example of that in a minute. Collaboration is totally new. If there's one reason we formed VANTIQ, the company, it was to keep humans in the loop. When I was a kid, I read 1984 and it was kind of scary. And of course, we're in some ways promoting it. When I say facial recognition everywhere, we're going to be tracking people in a way that is 1984. But at least let's do it in a way that keep people in charge of these systems. And I believe that is one of the biggest changes we're going to see in software development in the very near future. Okay, so events. I mentioned this already. You can't queue them. They need to be resilient. I'm a strong believer in resilience. In fact, I even have PowerPoint in case something didn't work, and I had to use this once. I have PowerPoint and this presentation on my phone with a HDMI SVGA attachment, and I could actually run it from the phone. I had to do this in China. The system didn't work, their connection didn't work. And so backup. In distributed environments, we get a huge benefit that there are many systems. And if a system crashes, the system should be smart enough to allocate other systems to take its workload. More on that in a few minutes. I mentioned the scalability. IoT devices are going to proliferate like crazy, and you build a system today, you need for it to grow. Now, where's the software going to run? There are elevator systems that are being built right now, and in Japan, that can reduce the number of elevators needed in a building by 20%. And the way they do it is by intelligently managing the flow regarding the workload. That makes total sense. The algorithms, where should they run? You ain't going to be running that in the cloud. You don't want to run an elevator system in the cloud. Besides, if you have fewer elevators, you're going to create big bottlenecks if all of a sudden latency or availability becomes a major problem. So you need to run those algorithms near where the systems run. And how do you get them there? How do you get those algorithms there? Well, you could change them or move them. Those are fixed locations. Then we have the mobile situations with mobile devices, intelligent vehicles, robots, movable assets. Finally, I believe RFID tags are going to become in vogue. They're going to be on everything. The RFID tag, intelligent tags that you can communicate to, they don't need batteries. They're only 6 cents a piece now. We know of a company that's putting them in all of their shoes, an athletic company. They're moving in that direction versus barcode scanners, because if you have RFID tags, you could read what's inside of a crate. So huge changes are occurring in physical sensors and devices. What all this leads to, again, complexity, lots of complexity. So let's talk for a minute about how does the software get there. So I said in a previous company we created an abstraction. This is basically abstraction for distribution. Wouldn't it be nice if you can create software logic in one location and then have the software logic automatically distributed to multiple locations? But this is beyond Docker or Kubernetes. This is talking about it could be a single rule, could be all different types of systems, has to be totally dynamic, no compiling, moved instantaneously while the system is running, and perhaps even simultaneously with changes in the cloud. These are complex management situations. So the needs reduce down to develop the applications in the cloud and then move the applications to where it makes sense. Move some of it to the cloud, some of it to regional offices, some of it to edge devices, some of it to intelligent sensors, some of it to these guys that we all carry with us, and make it dynamic. In fact, not just dynamic, but make it so the system can be aware of itself and either inform somebody we have a bottleneck, the data is not getting transferred quick enough, or automatically let the system measure itself and change itself. Simple things, more aggregation, more filtering at the edge, as an example. More complex things, let's not run the machine learning algorithms right now because they're slowing us down at the edge. And let's report that that's happening if you have machine learning running at the edge. I'm going to go through a lot of this quickly. I want to make one point here. There's efficiency needs that can be gained tremendously, and they're absolutely needed because cities are growing like crazy. You look at your city, almost wherever you live. If you live in a major city, look at all the building that's going on, all the cranes that are there. It's incredible. And those buildings are going to be filled with people. And then we're going to have challenges. So I spoke to the director of innovation for Los Angeles City. And her comment was, they're working with an SI, is that if we could reduce the traffic load by if we could increase the speed by 10%, I'm saying this wrong, if we could increase the speed by 10%, we get 40% more throughput. And that's what they're targeting. And they're doing intelligent lighting and management to be able to do that. That's a major change, 40% change if they can do it. And these cities absolutely need these kinds of systems to be there, or they're not going to function. The infrastructures will fall apart. I just picked on traffic, but everything else. What about waste removal, electricity, et cetera? I'm going to skip this. I'll just say the point that this slide was to make is that analytics can run at the edge. You can analyze machines where they're operating and take action where they're operating. And you will need to do this in the future. Not everything is going to go to the cloud. It's too much data. Some data, because you have to do the analysis of big data. But you want to be able to analyze what's happening, where it's happening, and then feed it back to the cloud for data scientists to do further analysis. Okay, next generation digital business applications. This require effective human-machine collaboration. This is, if I leave you with any thought this morning, this is the major one. We cannot take humans out of the loop. For the longest time, a few years I guess, we were talking about automating everything, automating the world. That's a great concept. Do we really think we can do it? How sophisticated is AI, or will AI be, in actuality? I have a son who's going for a PhD in neuroscience. And he knows I did some AI programming in the 80s, and I have some experience there. And we had this conversation, and he basically said to me that you computer scientists have no idea how complex the human brain is. And he thinks Ray Kurzweil and the singularity is just nonsense. He said to me, it took nature 4 billion years to evolve the human brain. There are 100 billion neurons. There are order of magnitude more connections than that. And there are things we don't even know about. And all the brain is basically used to do very complex things like intuition, generalization. And we're not going to get AI systems to do that for a very long time. I am not negative on AI. AI, where it's applicable, is one of the best tools imaginable. It'll help in retail situations. Machine learning will help extend the life of machines dramatically and optimize the utilization of resources. But it ain't going to be cognitive. It's not going to take over what humans can do, and will continue to do better for what I believe to be a very long period of time. If ever. As a species, I'm not sure we'll even last long enough to have true human-like intelligence in machines. But we'll see. Certainly I won't last enough, so I don't know if that'll prove true or not. So this is a quote from the Gartner Group. And I was really glad. We've been talking to them for a couple of years about human-machine collaboration. And finally, they're starting to talk about it, and I was super pleased with that. And they said, quote, in their keynote speech at their recent symposium, the secret to digital is analog, and by analog, we mean people. And I think we're ignoring the human factor. Now, this is going to change as we see more and more problems occur, and human factors are going to be, where humans are going to be involved more and more. Now, in this example, I want to tell you, now I'm a pilot, and pilots are 99% of the time totally bored. You just sit there, you do nothing. But that 1% of the time, when you're needed, you are absolutely needed, and your experience, your intuition, your actions are critical. Now, this is a vague area. Maybe some people say we're going to automate flying totally. We'll see. We'll see. Or maybe the pilots will be remotely controlling the aircraft on the ground. Not sure I like that one. But in these systems, the systems have been evolved, designed to interface to the human at exactly the right time. And I observed this a number of years ago. When the system tells me pay attention, I sure pay attention. And it's always right. It always says, maybe it's only a trivial thing, but maybe it's a significant thing. And it gets me in the loop at the right time. And I think this is a metaphor of how these new systems we're developing need to run. As I said, in complex business systems, the intuition and experience of humans is required to achieve valuable outcomes. We see it in field service, in retail, in airline operations. Now, I mentioned abstractions. So one of the major I spoke of abstractions over events. How do you take these events and analyze them in real time through very simple constructs? That is kind of the domain of a 4GL, though, right? You know, languages do that. I mentioned abstractions in how we distribute software. If you buy that software is going to be running everywhere, how do you get it out there? How do you manage that software? That abstraction of building the application in one location, breaking it apart, we call it partitioning, so that different parts of the application run in different places. That's an abstraction. It's been around for a while. We invented that, patented it actually, back in the 90s. But here too, we saw the need for abstractions. And the abstractions are, when you're dealing with humans, things like assignment. It's a very common abstraction. If you look at the Uber app, everyone here has probably used the Uber app. The abstraction is, you ask for an Uber driver, and the system says, find all Uber drivers within 1 mile that are not allocated, they're driving this kind of a vehicle, and assign them to the task, and then tell the other drivers that the task has been taken. Notifications, telling people when people arrive at certain locations, location tracking, on and on. I'm going to give a couple of examples. But these types of abstractions, if you believe that the human system interfacing, collaboration is going to be critical in the future, I would argue the only way to implement it is high-level abstractions, unlike any abstractions we've done before in system development, software development. So they're new. And if you could do this in a way that's relatively easy, if you could do it in a way that you could say the assignment is done with, say, drawing one box with default parameters, that the tracking is just done with another box until the driver gets to pick up the passenger, so on and so forth. So create those abstractions and make it very easy, visually in fact, to put them together to design a system. That, we believe, is the easiest way to do it. There may be others. There may be other approaches that come into the market. But with a system like this, and I'll talk about VANTIQ here, because this is, of course, our application development environment, our collaboration component. This system, you could build a basic Uber application, forgetting the databases, because that's a separate issue, talking about the human system collaboration. This system can be built in literally a few hours. And it's a requirements document too. You can sit down with the people who need the system and say, here's what I want to do, here's what I want to do. And then if you need to extend it, you want to be able to, you want to be able to add code or change code for any of these boxes and modify it for the particular situation. But this is a level of abstraction that has never been in the industry before. And we believe if collaboration is needed, and we believe it's definitely needed, that systems like this are going to be the absolute requirement. Here's a failed service example. And I'll go through this example quickly. Time is running out fast. Machine fails, assign a technician. The system and the technician work together. The system uses AR when appropriate, or tells the technician, use VR, pick up your glasses, make a change after you looked at it. So these are intelligent systems. I'm not going to, for time, I can't go through that. Airline operations. Now here's a complex system, and take a look. There are all types of things, aircraft changes, aircraft events, security operations, but look how frequently humans need to be involved. This is not going away. Humans are going to continue to be need to be involved at the right time, doing the right thing. Security. Collaboration is critical for security. I'll just quickly mention a few examples. Logging. Somebody mentioned earlier today. If there are anomalies in the logs, you want to tell people. Well, I don't know what action they want to take, but they want to know about it. If you need approval for certain things to happen before they happen, there could be a security breach. You want people involved. If somebody walks into a room and the system recognizes them through facial recognition, and they want to do something in that room, start up a machine, before they physically do that, you know they're in the room, and then they could press the button. So two-factor authentication. Maker checker, we're familiar with that. One person does it, another person approves it. And then ultimately for security, one of the things that we believe you're going to have to be able to do, these are naturally distributed complex systems. When things go wrong, like anomalous behavior, break up the network, at least limit your exposure. You don't want to bring back down the whole supply chain. Maybe you want to bring down one assembly line or one plant. And the system should be able to do that with human guidance. Next thing I want to mention is all this has to be done quickly and while the system is up and running. And you need to be able to modify these systems quickly. There's a whole trend now called microservices. If you go to the programmable web, it lists about 18,000 microservices. You get information on almost everything. Of course, there's Google. We all think of that as an example. Weather. What about CDC, which tells you where diseases are happening? You want to analyze, hey, there's something going on in southern LA where the same disease has been reported at these 5 different hospitals in this location. You can include those services as they're developed very easily in the system. That's also a requirement. So in summary, complexity is rapidly increasing, quicker than ever before. But we're not going away as a species. We got to figure out ways to deal with this technology. And the technology, the AI and the AR and the VR and the IoT devices is only going to grow like crazy. And I would argue that the only way we can deal with it is through abstractions, high-level abstractions, new types of abstractions. Otherwise, every high school graduate will have to be a Java programmer. And that just is not going to happen. There needs to be a solution. Abstractions are needed in all 3 areas I mentioned. And software is going to eat the world. It's going to happen. And let's try to control it, keeping people in the loop. Last slide. A couple of things to think about. We're no longer just automating how businesses run. We have to reinvent business processes. We don't want that 40% of the current large companies to go out of business. That's crazy. We want them to be able to innovate and innovate quickly. And the types of areas I think are going to happen first, somebody asked us, where's IoT going to be most effective? What we're seeing, safety, health are some of the areas that are going to grow very quickly. Also, assignment of people. That's an app that we've seen 3 or 4 applications being built now, the technician type of app. Cybersecurity requires new thinking, as I mentioned before. Breaking up networks, splitting things apart in a controlled manner. Let humans make those decisions, possibly systems if it can be programmed to be automated. All of this stuff, after it's built, it is going to evolve so quickly and change so quickly that absolutely required are high-level paradigms, high-level abstractions. Or we're not going to be able to evolve these systems quick enough. Or the guys who built it leave and the company's in trouble. And then the last 2 points I want to make is there will be discontinuities. Strange things will happen. And when they happen, we need to keep people involved. And also another phenomenon called emergent behavior. Things may happen we never even thought about. And we have I've already seen a couple of examples of that, where thieves were able to figure out how the system worked and broke into a convenience shop based upon automation that they knew was there. That type of emergent behavior needs to have humans in control to stop it. So I've gone through a 40-minute presentation in about 30 minutes. I've gone very quickly. And I think my time is up. So I thank you very much.